Okay, this is going to be a problem like 23 through 32. For each of these problems, you're going to be given a function value and you're going to be given a constraint. And using those two things, you're going to narrow it down to one quadrant. Both of them give you two quadrants, and they will both match up in one of the quadrants. For instance, let's just do an example here. Let's say I was given tangent of theta equals 3. And I'm also told that cosine of theta is less than 0. Okay, well, let's start with the cosine is less than 0. That's a little bit easier. If we use our chart, we know that cosine is x over r. And if cosine is less than 0, that means my x has to be negative because r is always positive. I repeat, r is always going to be positive. So if x is negative, okay, that puts me in quadrant 3 or quadrant 2. Okay, x is negative in these two quadrants. Right, the other piece of information I'm given is tangent is 3. Well, that's 3 over 1, but it could also be negative 3 over negative 1. Okay, because negative 3 over negative 1 would also be 3. Okay, so which two quadrants could I be in for tangent? Well, according to the sheet, when tangent is positive, tangent is in quadrant 1 or quadrant 3. And now we look at these two diagrams here, and we should be able to tell which quadrant we must be in. We must be in the third quadrant because both of these match up in that quadrant. Okay, so if we're in the third quadrant, both our y value and our x value must be negative. So let's draw that picture. Okay, so tangent of theta must be negative 3 over negative 1. This means that my y value is negative 3 and my x value must be negative 1, which puts me right here. And I'm just going to draw this triangle bigger so we can just see it a little better. Okay, so we're in the third quadrant. This is a right triangle. My y is negative 3, my x is negative 1. We can use Pythagorean's theorem to find the radius or hypotenuse. So we would take 3 squared, and it's actually negative 3 squared plus negative 1 squared. Negative 3 squared is 9. Negative 1 squared is 1. You get 10. So this side is the square root of 10. Sine of an angle is y over r, opposite over hypotenuse. And now that we have our triangle, we can we're looking for this angle, but we know it's going to be the exact same functions as this angle inside this triangle once we have it drawn properly. So the y will be negative 3 over square root of 10, which we rationalize. Negative 3 square root of 10 over 10. Okay. Why don't we just go ahead and do the cosecant too, since we just did sine, and we know cosecant is r over y. Sometimes when you rationalize, it's easier just to go back to the original data to find cosecant, because the original data for r is square root of 10, and the original data for y is negative 3. This is easier instead of taking the reciprocal of this, because if I take the reciprocal of this, then I have to rationalize it. So sometimes it's easier when you're finding all 6 functions to just go back to the original data when you're doing the reciprocal part. Okay, so this would be sine and cosecant. Cosine, x over r, adjacent over hypotenuse. Both of those would be the same. The x value of this triangle is negative 1. The r is the square root of 10. The adjacent is negative 1. The hypotenuse is square root of 10. Both of them are the same. So this would be negative 1 over the square root of 10 multiplied by the square root of 10 over the square root of 10. You get negative 1, negative square root of 10 over 10. secant of theta would be r over x. R is the square root of 10. X is negative 1. So you get negative square root of 10. Tangent was given to us. We'll switch colors. Tangent was given to us in the problem. Tangent was given to us right here as 3. So if tangent is 3, cotangent is 1/3. I hope this helps.